All right, hello everyone. Yeah, so let's talk a little bit about what's going on. So if you right now the benches, there's a huge memory leak in the garbage collector. So I'm going to run the SC Lang bench, which I created. And I added some memory tracking statistics to this some printing out some statistics to try to understand. Oh, but of course you have a broken thing. I was right in the middle of source the RS. This is going away anyway. Okay. Okay. So that's enough for our purposes. So you'll see this stats diff, allocated bytes, allocated objects. So cycle count. So this is how many times has the garbage collector run entirely through its collection list, like gone through all of the phases of garbage collection and like done all of the work, and it has no reclaimed objects. Hasn't reclaimed a single object. This reclaimed bytes, you'll see, is non-zero, but that's likely because I'm tracking Rust like memory allocation. So if you have a vector, for instance, that gets resized, it'll free the old internal container, and release it. But you can see already that we're at what is this? This is 43 megabytes of memory allocation across 295,000 objects, and with nothing reclaimed. And this isn't just like, if I let it run for a little bit longer, you'll see that the CD one takes a little while. We might be here a minute. But you can see if I look at my memory available, well, nothing's eating more than Chrome right now. But yep, we'll start to see bench cropping up here. Cargo, there it is, 1.5 gigs. Now we're north of 2 gig, 2.1. So my thesis is that we are never reclaiming memory. 2.5 gig. We go look at top. Just watch this. Oh boy. Yeah, and it's single core, so it's not good. There it is, SC Lang. It's burning up a core, single core, mem. Yeah, this is just like what it's adding. Look at all these page faults too. Like this thing is. That's just. Yeah. Okay, so we got it. We got through CD. So still, you'll see now way more allocated bytes. Okay, reclaimed bytes, but no objects being reclaimed. And so, that's kind of the mystery. So here's the garbage collector. We are incrementing objects here. Here it is. Wow. 0. Obj. So is the finalized queue never? I'm just a little curious. Okay. So we are marking things. We get to scavenge. I'm kind of wondering, we should log, okay. I think the tracing is really handy. You could also step through it with a debugger, but something is. But I've been wanting to see a perfetto tracing this thing for a while, and it's going to be useful for benchmarking. It might be a flight of fancy, but I don't know. You know, it's a hobby project. Maybe I don't have to be absolutely disciplined all the time. Okay. All that said, I had decided against adding this feature here, and instead, dependencies, you have a tracing perfetto, you're going to delete that. I had an optional dependency feature, and instead we're just going to put it right in the bench. Like, we're just going to make another argument for the bench to say, hey, save a trace. So those are dev dependencies, pretty PQRST tracing, I think it's perfetto. There we have it. Okay, so now we're going to go line bench sc line.rs. We're going to add an argument. And the argument is perfetto path. So we have this perfetto tracing, perfetto crate. The documentation's real minimal. Okay. So I had thought one trace per benchmark. These are going to be enormous. But for now, I think we'll just do a trace file and just log it all in one. Okay, so the argument is something like trace file. It's in alphabetical order. This is an option. Equal T. Have to record a perfetto trace file to option string. Yeah, there you have it. Okay. Compile. if args dot if let some path equal args dot trace file. What we want to do is the tracing subscriber is really important. Tracing subscriber, because it needs to be in context until the option is a what is that here? I need to learn more about the prelude idiom in Rust, because it seems like a one that you see in libraries that have you include a lot of junk, that could give you a lot, not junk, just stuff. And this is going to be a layer. I think it's going to be a perfetto layer. Layer equals sum. Create path. Oh, there's stuff here. Let's go. Dot unwrap. Okay. We have tracing subscriber. This might be a crate that you are missing. Yeah. Actually, I don't know. And you just run it until you're done. That layer. Oh, this is fine. Tracing subscriber, registry with layer. Class library. Registering. To this we should get what? Okay. Oh. You haven't provided it here. How do you tracing dash perfetto? Here. Dependencies, tracing dash perfetto. Okay. I don't think you have tracing subscriber. I think it's going to be like, what is this? I don't know what you're talking about with this tracing. Well, there it is. It pulls it in as a dependency. I don't like that. Yeah. Okay. Cool. Yeah. C++ will let you get away with that, but Carbon will not, or Rust will not. Anyway. Parsing equal put it here too. Okay. Okay. Okay, fine. Okay. Okay. This registry thing. Minus T. Why not bounce? What are these files called? Supposedly, these files are called pf trace. Oh my god, okay. So now, it's 277 make trace from, wow, a significantly slower benchmark. But tracing totally enabled there. What happens if you don't supply the trace? I'm just curious, does this still run? Okay. You only pay, this is nice, you only see, look, that's a more typical time that we're seeing for bench, whereas, you know, bench took 3 seconds, but it's because it generated, you know, 700 and some odd megabytes of data in that time. I want to open up Perfetto. Trace viewer, UI.perfetto.dev. Open trace files, bounce.pftrace. Yep. Wow, this thing is crazy. Okay. So instead of this, we're at this, I think we're going to do this Chrome window. All right. First of all, we really need to zoom in. Okay. Okay, yes, we're using cookies. I'm sure Google is. Wow. Okay. I know there's a way to zoom in. How do you zoom in? Hey. I need help. It's been a minute. Keyboard shortcuts. Click, zoom in and out. Control, scroll wheel, click, drag, pan left, right, click, select event. Control, scroll wheel. Ooh. Okay. What are these? Just tell me. GC mark. We don't seem to have the... Doesn't seem to have the annotations that I added. Mark.mark. Just mark.gather roots. GC mark init. Gather roots. Why is this so... 1 microsecond? Mark.mark. GC mark. GC mark.mark. GC mark.mark. What's this? GC.mark. GC mark.mark. What was the... Oh, yeah, okay. You can use WASD. Oh, that's cool. Okay. So we never seem to get past marking. What's this? GC mark.finished. GC scavenge. Okay. Scavenge.init. Okay. So scavenge, it looks like we hit scavenge and we never meanwhile, where's the main? Huh. Okay, well this is working. I think it's enough for PR, and then I think we can fix the from there we can fix the code. I think I'd like to ultimately also add it to Hadron and the Hadron command line and develop a set of tools which are like common code, you know, put the Ariadne error formatting in there, put the perfetto tracing in there, things like that. But for now, I think this is great. This is enough of the tooling. I think that let's just make sure everybody's happy with our code. That's pretty neat, a burrito though. Okay, and let me do the web testing real quick. To make sure perfetto doesn't break anything in WASM. Shouldn't. Oh. Get random. So one of the depths is let's run this again. There it is. No, there's no dash. So this is in rand, which is a depth of tracing perfetto. Okay, so I think what we have to do, unfortunately, I'm glad I ran the web tests. Cardinal dev dependencies. So cute. Dev dependencies, and then we can go target.not config target arch, I think not target arch equal wasm 32 dot dev. Over here. Okay. Yeah. Okay. Make sure bench still builds. Okay. Oh, okay, we're happy. Okay. That's a PR. I mean, I think, yeah. This view needs to be way zoomed in. this is this is the bug that we're working on. This one, number 470. It's likely to be let's add a key so cargo bench minus bench SCNA dash L source bench minus T dot get trace. Then you will get a file saved in your home directory, which can be visualized at ui.perfetto.dev. Cool. Very good. Very good. Oh, I don't know why this is so cropped looking. We kind of didn't. I need to prepare a web browser before I broadcast. All right, so we got the pipeline. Oh, I see. It's like making the window. That's not what I wanted. I gotta figure out a way to. Okay, well. Android. I think what we gotta do is fit the window. We need scaling on it, I think. Give me your bottom corner. Oh, the OBS user interface. I wish I was better at it. I have it. So now when I zoom this in, hopefully, it works. We're waiting on the web build. We're always waiting on the web build to merge this, but we can zoom this in too. 300. I think that's pretty reasonable. And now you can see what I was seeing with the Perfetto UI. So it looks like we go GC mod, then we go, it's a stats allocation statistic that isn't making its way into Perfetto, which sucks. GC mod, stats allocated, what was this? This is something, probably an allocation. Then we go GC scavenge. We spend a tiny bit of time in there. GC scavenge init. That doesn't seem to be stacked. GC mark init, and we went from scavenge to mark. Like there was no So scavenge doesn't do anything. What are these? Gather roots. Mark. Mark. Okay, so we marked some stuff. Cool. Mark. Mark.mark. Stats allocator stuff. DC mark. Mark.mark. DC mark. Mark. So we're marking. Mark. Mark.mark. 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 Mark. Mark. Then we go mark finished. Scavenge. Scavenge in it. Scavenge, scavenge. Scavenge finished. Like, nada. And I don't see, I thought I had added some tracing to eval. Finalize. Reclaim. And then we're back to mark. Like, okay. This build's happy. This one takes a little longer. Heck. Time to add the camera back into this view. Capture device. Not existing. This one. Okay. It's always super huge. Let's put you down here. Great. Cool. Okay. Compilation times. Okay. I'm going to presume that we're off to a good start here. Let's just go look at the file. Okay, so we mark, but we don't seem to scavenge anything. Next, so phase next. Stats, garbage collector. So we're in mark, state. The next phase is phase scavenge. Into the default. That's the default state, isn't it? So mark. Okay. So we check it. Is it the epoch color? Then we go oh, okay. So we pop one off, we keep going. Mark state is finished. Mark color. When in it, we go mark color dot flip. Okay. Okay. Oh. No. Okay. So now we go pop one. Look at it. I am looking at my terminal. Here we are. In the background, I'm going to merge this this pull request. Cool. Okay. Ta-da! It's not recording everything that I would want it to record in the perfetto trace, but we'll see. Okay, so okay. Now we're in Mark. We're pulling things for the upper card. We mark them as gray. Let me keep going. That's weird. Where's this while loop? Okay. No, the while loop is here. Okay. So we've said, okay. Finished. Mark finished. We flip the color. I am seeing that in the perfetto trace, right? Like there's some mark finished thing. Yeah, I think I saw it. Mark, mark, mark. Yeah, do you see mark finished? Okay. So we do pass through this. We do flip the color. Scavenge. Okay. Are we pushing to the finalized cube? Yeah, here. Okay. Okay. Spiral. Okay. Stats. Take. It's black's the default. We start with black, right? Headers always starts gray. New objects always start as gray. We go. Oh, they are not getting added. Huh. That means they need to be pushed to the work list. So when we take unprocessed live objects. Take self mark Q, push back. Push back. Okay. So everything's in the mark queue. We go scavenge. Now we go unprocessed live objects. Should be empty. And then we look at live objects. is getting put stuff in it. Yeah, you're never putting anything in live objects. Oh my god. Take. You need to have it in both. Oh, that's really annoying. That's going to be our thing. Ah, okay. Goody. Progress. 3. Set lines. I have to remember how to get bin to turn on. Set number. The entirely intuitive set number command 376. So this isn't scavenge. No, it could be gray. No, it really can't be gray. Yeah, something's weird. So we have it in live objects, right? So mark, it's in the unprocessed roots. We go from there, but we also have the mark key. Yeah, so we're putting it in the mark queue and we're putting it in live objects. So live objects is supposed to be the list of everything that we have, that we know about, every piece of memory that we've allocated, because we aren't doing zone allocations right now. And so it's supposed to be everything. And then, okay, so we say we are also putting all the roots in the mark queue as well as marking them gray. So the invariant in the mark queue is that everything everything must be marked gray. All outstanding allocated objects unprocessed. Okay. So so we've got everything in unprocessed roots. We go there, we flip them. Continue, borrow root. What are you doing with the unprocessed roots? like you're emptying your roots all the time now. Self.roots. Oops. Yeah, so you self.roots.push back because keep this is alive. Okay. Okay. Mark state mark. So we go through here. We're going to mark better be gray. Okay. Some mark object. Good. This object is unmarked. Mark it. Back. No. One. Curious if that bug was the bug. No. Or matte or gray. Let's add them in. I love my assert right here. They're both gray. Yeah, that's okay. No, you're looking at the wrong thing. 379. Here we are. Yeah. Color got match with gray. That's one way to do this. Get rid of the assert. And that always reads better to me. There we are. Let's see. I think you might actually be getting a seg fault because you are now actually garbage collecting objects and you weren't before, and so it's like this thing that the garbage collector has collected is it was now nil because I went and set it to nil because the object's on the reclaim list. Yep. I bet you. Let's look at Rust backtrace. This is here. Garbage collector to work. That's very interesting. Yes, I want a glass of iced tea with ice in a glass made from glass, and iced tea made from tea boiling in leaves. Oh, we don't get line numbers. I'm wondering if these will backtrace now. We could also just run dev profile. Yeah, you are wreaking havoc in the tests. Yes. I knew this day would come when the garbage collector becomes very sad. You are... Okay. Minus P... what's this name of this package? This chicken has come home to roost. Can we run this thing? Is this the name of a test? I think it is the name of a test. Minus test. Okay. You know. Let's go look at this test. Collection. Why are you using SC? What are you doing? Doom. Test. Function block. Everything's cool. Empty. it just self-referential, or is it all of the garbage collector tests are now math? I have a feeling we just found this out that we're going to crash on another one of the garbage collector tests. But I'm a little curious. Yeah, basic alloc. Cool. Okay. It's just basic alloc now. Get code. Yep. Lake location. Yeah. I mean, you should add root, like, get rid of this one. Yeah, no. Blows up. Failed to cast nil to laying runtime collections array. Oh, okay. But we survived this one. So here's the thing. Link is already out of scope. So if you force a full collection, it's going to like mark it and scavenge it. And then you're going to try that borrow is failing on line 30. So yeah. I think that one will be okay now. Let's check this one. This one's going to fail because okay. Yeah. Okay. So self-referential is Okay, cool. Okay. We still have the thing on the top right now. Just down here. You're not using this, and this is really crazy. You should be using this. You should be using this everywhere. It just holds an edge. See the backtrace. So yeah, actually, all right. First of all, I assert that because link has been added into the root, this should work. Basic alc also failed. Okay. We can just go cargo test. Oh yeah. Okay. Backtrace, right, backtrace. Boxed thing is panicking. Okay. The tool chain result. inside of finalize. 414. Line of 414. And what's the error? Cast failed. Buffer's just small. That bar move is failing. Is hungry. Oh, yeah. SC set. That's where it fails. SC set. Boom. Hadron air, which is pretty wild. Let's look at SC set. I think that's in SC. Nope. This is going to be source lane, source runtime, for objects. There's the implementation of SC set. I feel like there's these are all, they can't be nil. GC's at the top. is Dyna ceiling. I'm gonna take a break. Thanks for playing though. Back to the practice guy. Might stream later in the afternoon. Might not, depending on the mood.